Our demo today will focus on a company that has two manufacturing plants. The first factory manufactures coffee machines that are sold mostly off the shelf and sometimes per specific customer requests. The second factory manufactures coffee capsules for the coffee machines. Most of the manufacturing takes place in-house, whereas certain parts of the process are done by subcontractors. We will use this example to show various types of demands and how they affect the planning process. Let's start with the first type of demand, the sales order. In order to show you the sales order, I'll open Priority's mobile app. In our example, the company's sales rep goes out into the field with Priority's mobile app to meet both existing and potential customers. One of the existing customers would like to make an order for a monthly supply of coffee machines and coffee capsules. The sales rep and the customer choose items out of the catalog together. The catalog consists of personal recommendations based on recent purchases, upsells, and cross-sells. We can see the real-time availability of the items and the pictures, of course. In our example, we will pick this coffee machine right over here, the one that costs $150, and I see that I have 5 available in stock. The customer originally wanted these capsules, the ones here that cost $1.20 per capsule, but I saw that it's out of stock. So we settled on coffee capsule number 3 that costs a little bit more, which is the one right here. So if I check out the order confirmation, basically what we have here is a mixed sales order involving items that belong to 2 different production plants, the coffee machine manufacturing plant and the capsule manufacturing plant. Now that our order is ready, and to make things official, the sales rep quickly and easily records the digital signature of the customer. Once signed, all the data is sent in real time directly to Priority, and this order immediately takes part in the planning process. In addition to the ongoing day-to-day activity, there is also a demand for a special industrial coffee machine. It has already been processed by the back office and is ready for the customer's approval. The customer receives this price quotation that you see here on the screen for a new prototype and uses this Sign Now button on the bottom to sign and approve the request using a smart digital process. The approval is immediately saved in Priority, and then a notification from Priority's Automation Hub is sent to the engineering and sales teams automatically. Let's go to the back office to see how this plans out using the personalized widgets on my homepage. In order for us to be able to easily manage and track the project during its whole life cycle, from pricing to planning, execution, manufacturing, we're going to kickstart a new project in the system. Now, the project, as you can see here on the screen, is made up of multiple steps, some of which are production related, and some of which aren't, such as design, technical specs. We estimate the resources needed for each step in the project to better understand how to price the prototype and still maintain profitability. Besides the project and the sales order, another source of the planning engine is the sales forecast. The forecast takes place on a periodic basis. Each company can decide on the frequency. The parts are detailed here with the quantities. Now, this is typically calculated by the system on the basis of previous period's actuals or with the help of an intelligent integrated AI tool. But ultimately, it can also be uploaded from a spreadsheet. Now, we're going to look at the planning analysis results for each one of the production plants. We will start by looking at the coffee machine plant that practices discrete manufacturing. Here, we can see the planning analysis and subsequent actions that the system automatically produced, including opening work orders based on all the sources previously mentioned, as well as safety stock. The inventory on hand for the coffee machine is shown in blue. In red, you can see the generators of the demand, and in green, the generators of the supply. By the way, this ability to display data in different colors is just one of the many customizable capabilities that Priority offers to help maximize and personalize the user's experience. The planning process automates the procurement as well, kicking off the supply chain by creating purchase requisitions, which can then be converted into POs. Let's move on to the water container, which is one of the purchased parts. Here, we can see the projected balances for raw materials. Again, the inventory on hand is shown in blue, demand in red, and supply, actual or recommended, in green. As you can see, when POs are in place already and their expected delivery date falls short of a demand that might use them, the system suggests to expedite the supply. Other types of supply are the requisitions, and those can be converted into POs. Now, let's see how the planners can take those details into the scheduling phase. Using this visual drag and drop Gantt, planners gain visibility into the various work cells and their expected loads. If the planners would like to move a work order to an alternative work cell, they can easily do it. The system has built-in controls to make sure that moving operations on the Gantt chart abides with all business aspects. The planner can also click on one of these bars and zoom into a specific work order. This work order is not just a standard work order. It's the work order for the prototype that our customer has asked us to build. So before we start manufacturing, let's go back and talk a little bit about the engineering process that led up to this point. As you can see, the BOM revision in this work order is A2. Because this is a prototype, we opened a special part revision for the engineering process. If we drill into the coffee machine, we can see that there are a few purchased components, which are the drip tray, multimedia, temperature sensor, water container, and one subassembly, which is the heating element. The PLM software integrated into Priority is typically where the engineering process starts, defining BOMs and layouts, and then seamlessly continuing in Priority with ECOs and component sourcing. The planning takes the relevant, current, or future BOM revision into consideration. Here, we see the ECO for this coffee machine. One of the great things about Priority is that I can easily navigate from anywhere to anywhere. So what you just saw is me zooming into the ECO from the coffee machine to see some more information. Some of the things we can manage in the ECO are the implications of the change. In some cases, the result of a specific ECO may be a decision of a system-wide change of a component in all coffee machines, and this can easily be done with the click of a button. For a clearer understanding, the engineer can also attach a blueprint of the mechanical design of the coffee machine or any other relevant attachment that may be of interest. Subsequently, many decisions can be made, such as deciding that a specific component can start being produced by a subcontractor in partial or full turnkey. Going back to the ECO, it now needs to undergo approval with all the relevant parties in the company. I will use this shortcut that you just saw to access the ECO's BPM. The intelligent approval process is carried out using Priority's graphic and flexible BPM tool, as you see here on the screen. And we use it to build automated business processes. Now, this robust functionality is available across the whole platform and allows companies to customize and enforce their internal procedures. As you can see here, some of the functionality includes push notifications, webhooks, automatic emails, and more. Back to our story. Now that all the special requests have been approved, we can start production. As you can see, these breadcrumbs tools enable me to go back to where I was before, a few stages ago, so I can easily navigate back to the work order from this ECO. This work order has its own BOM that came from our specific revision A2, like we talked about before. We can change one of the part revisions, one of the components, or even change quantities. This is especially useful now that we are working on a new prototype and changes need to be made. The same thing applies for the routing as well. In every work order, you can see the progress that has been made. Of course, the production reporting can be done using handheld devices, and the results are displayed here on the screen. The subassembly, which is the heating element, as well as the final assembly, which is the coffee machine, are serialized, and I want to show you how this is reflected in the production reporting progress. So let's move on to production reporting. As part of the production process, I can specify the serialized parts by barcode scanning or automatically as a batch of serial numbers. During the entire supply chain process, the connections between the serialized components are maintained from production to customer through rework, RMA, and such. Finally, let's look at the results of the analysis conducted during the production process. During the reporting, the user automatically received the list of required tests and then reported the results of the measurements collected. Some of the tests were manually reported, such as visual tests, and others were automatically reported using cameras and sensors on the shop floor. In the end of this process, a COA can be produced, like the one you see here on the screen, and it can be attached to the finished product. By the way, printouts in Priority are self-service and can be easily customized by the company to fit their specific needs and can be generated automatically in the customer's native language. The coffee machine's life cycle obviously doesn't end here. We will keep tracking this machine even when it has left the company's premises. For example, you can see here that this specific machine was initially produced with this serialized component, but later on, the built-in sensors in the machine picked up on a malfunction. The machine was serviced, and the component was removed and replaced by another. In addition, this machine must also undergo preventative and predictive maintenance to keep it up and working and to reduce the risk of malfunction. The system has also put into place a periodic maintenance plan for the machine. The plan consists of a quarterly thorough cleaning and changing of the heating element every 3 years or every 50,000 cups of coffee, whichever one comes first. We can also see the maintenance history of the machine right over here. Now, let's circle back to the project and see how all these activities, including the manufacturing, affected the project's results. The project incorporates all the business-related activities, providing real-time project tracking and monitoring of all the financial health of this project. Here, we can see the actual and projected costs that the project now bears in the form of issues to kit, labor costs, machine costs, unbilled GRVs, and more. Here, we can see if our project was at all aligned with the end result. This view unveils the total planned, actual, and projected costs of the different project activities, providing the company with the ability to track and successfully maintain the budget. So now that we saw typical discrete manufacturing that also included a new project with customized manufacturing, let's have a look at the planning in the capsule production plant, where we will see process manufacturing take place before we go on to distribution. This is our part representing the coffee blend. The blend is produced on our site and then capsuled by a subcontractor. The capsules are made to stock on a regular basis and are sold alongside the coffee machines. First, let's take a look at the formula that makes up the blend. You can see that this blend is made up of 0.8 kilogram ground coffee and 0.2 kilogram natural flavors. Both the coffee and the natural flavors have a scrap percent set up. This signifies that we would usually need more than the defined quantities in order to produce 1 kilogram of flavored coffee blend. If I try to change a value in the formula, I won't be able to because it requires special approval. This again is one of the built-in controls that can be defined for process manufacturing by the company. The flavored coffee blend has a complex production process routing. The various operations in the production process take place in 3 different machines: the mixer, the slow mixer, and the dryer. Here we can find many different settings that affect the planning, such as setup time, buffers. These machines also undergo preventative and predictive maintenance, just like I explained before when we talked about discrete manufacturing, so I won't repeat this process again. Now that we understand how the plant works, I want to move on to receiving the raw materials. As you can see here, we received 1,000 kilograms of ground coffee and 500 kilograms of natural flavors. The quantities are based on the purchase planning we talked about before and takes into consideration safety stock. The raw materials are received with their lot numbers and corresponding expiration dates. I chose to receive the raw materials in the quarantine status, which means that the laboratory team must approve the materials before they can be used in the production process. Typically, the lab has predefined tests set up for each type of material. The tests are automatically measured by sensors, machines, and other devices, and the results can be seamlessly read by Priority to conclude if the tests pass or not. In cases where repetitive tasks must be performed, Priority's automation hub can be used. In my example here, I can see that a portion of one of the raw materials was rejected, and this might have an impact on the vendor's rating. Now, let's have a look at the production reporting. In our case, the entire reporting process is done automatically by the MES system. It takes care of choosing the lots and reporting actual consumption along with any other data and sending it back to the ERP. Let's zoom into the work order itself to see the work in process. In this example, 5 kilograms of the coffee blend are in the first production step, 25 kilograms are in the second production step, and 6 kilograms have been sent to a subcontractor for filling up capsules. Naturally, Traceability throughout the whole process is very important. We can see here how the specific coffee blend lot was sent to the subcontractor in order for it to be capsuled and sent back to us as a specific batch of coffee capsules. Of course, all the costs in the process, such as shipping and work, play a part in the profitability. Now, traceability doesn't end here. If your vendor reports a problem with one of the lots, all of the work orders and shipping documents that this lot affected can easily be found and recalled if needed. Managers can track vital production data in real time using Priority's production management dashboard. This view is fully interactive and customizable and contains many analysis options such as inventory value and production costs. Okay, so we saw the production processes in both our plants, including the subcontractors part. Now, let's move on to the distribution. The first step is the pick and pack mechanism, which is part of Priority's inherent WMS tool that helps us perform automatic and optimized warehouse processes. As you can see here, it is made up of smart algorithms that define the company's picking strategy. For example, FIFO and partial fulfillment. The capsules have a smart algorithm based on fulfilling earlier expiration dates first and maintaining minimum batches per customer, whereas the coffee machines have an algorithm based on weight and volume. Once the coffee machines and the capsules are picked, packed, and ready to be shipped using Priority's shipping mechanism, we will send the capsules with our internal drivers. In the coffee machine plant, typically external shipping service providers are used. For distributing coffee machines, we will use our seamless integration to various shipping providers, such as FedEx, UPS, and others, to easily quote, execute, send, and track the goods to the customer right out of Priority. For distributing coffee capsules as a self-distributor, the company can easily print labels for the packages using this button on the top of the screen. Now I'll move on to show you our proof of delivery app for drivers. Drivers' shipping routes are automatically planned using route optimization algorithms, and the company receives the truck loading plan for the execution. This step makes sure that what is needed to be loaded in the truck is actually loaded, helping minimize critical human errors in the loading process and ultimately enhancing customer satisfaction. The truck drivers automatically have their whole route mapped out for them. As I mentioned before, the optimization algorithm has planned every detail of the route, including the drop plan as seen on the right over here. GPS tracking of the driver is activated for the company's needs and to help manage and track this mobile workforce. When the driver makes a drop, an unload verification control is put into action to make sure that each barcode that is scanned belongs to this order. Important notes are available as well. Next, the customer digitally signs and accepts the shipment. Pictures and driver's remarks can be added at this point. And of course, all of this is available in Priority in real time, saving the back office a lot of hassle doing this manually after the driver has returned to the office. If this drop happens to be a return and not a shipment, the driver can easily take the goods back, including the reason for the return. Upon confirmation, a return document is automatically available in Priority in real time as well. In conclusion, our demo today focused on a company that has two manufacturing plants, one for discrete manufacturing, including projects, and one for process manufacturing. We use this example to show various types of demands and how they affect the planning process. Of course, those were just a few examples of manufacturing processes in Priority. We have clients who manufacture molds, gaskets, extrusion, fashion, electronics, and much more. Thank you very much.